What if you were falling into a black hole right now, and you had exactly 60 minutes left to live, and the most terrifying part wasn't the dying. It was that from where you're standing, nothing would look wrong at all. Sit with that for a second. You wouldn't feel a jolt. You wouldn't hear an alarm. The stars around you would still look beautiful. The universe would still feel vast and calm and almost peaceful. And yet, every single second that passes, you're crossing closer and closer to the most violent, most extreme, most mind-breaking place that has ever existed in the entire 13.8 billion-year history of our cosmos. A place where the laws of physics, the same laws that govern how your heart beats, how light travels, how time itself flows, those laws begin to crack, bend, and eventually shatter completely. And here's what makes this truly different from any other "what if you died in space" scenario. This isn't just about dying. This is about experiencing something that no human mind was ever designed to process. Because inside a black hole, reality doesn't just end. It transforms into something that our science cannot fully describe. Our greatest equations break down. Our best telescopes go blind. Our most brilliant minds, people like Stephen Hawking, Kip Thorne, Albert Einstein himself, they all hit a wall when they try to explain what happens beyond a certain point inside a black hole. And that point has a name. It's called the singularity, and we're going to walk toward it together, step by step, minute by minute, second by second. But before we start the clock, before we begin your final 60 minutes, I need you to understand something that most people get completely wrong about black holes. Something that even some science channels skip over because it doesn't fit neatly into a clean explanation. And that thing is this: a black hole is not a hole. It is not empty. It is not dark in the way you think of dark. A black hole is actually the most densely packed object in the universe. It is matter compressed beyond any limit we thought matter could survive. It is gravity so extreme that it doesn't just pull things in, it reshapes the very fabric of space-time around itself like a bowling ball sitting on a stretched rubber sheet. Except instead of a gentle curve, it creates a tunnel that goes infinitely deep with no bottom. And you are about to fall into that tunnel. Now, the black hole we're sending you into today, let's make this feel real, is a stellar mass black hole. Not one of the supermassive giants at the center of galaxies that could swallow our entire solar system without blinking. This is a smaller one, roughly 10 to 20 times the mass of our sun, collapsed from a star that died billions of years ago. It sits silently in the darkness of space, completely invisible to the naked eye, bending light around it like a cosmic funhouse mirror, surrounded by a swirling disk of superheated gas and plasma that glows brighter than most stars. And somehow, impossibly, you are here, close to it. Too close. Let's start the clock. You have 60 minutes left. Right now, in this moment, you are roughly 1,000 kilometers away from the event horizon. That's the point of no return. The invisible boundary where not even light, the fastest thing in the universe, traveling at 300,000 kilometers per second, can escape. And here's the first thing that should shake you. You cannot see the event horizon. There is no line drawn in space. There is no flashing warning sign. It is completely, utterly invisible. You would cross it without knowing. You would cross the most significant boundary in the known universe and feel absolutely nothing. At this distance, 1,000 kilometers out, the gravitational pull is enormous but not yet deadly for you. You would feel it as an acceleration, a gentle but persistent tug pulling you inward. Around you, the universe looks distorted. The stars behind the black hole are not where they appear to be. The light has bent around the event horizon like water bending around a drain. So you're seeing stars that are actually on the other side of this monster. The sky around the black hole looks like a dark circular void surrounded by a ring of warped, stretched, impossibly bright light. Physicists call that ring the photon sphere, and it marks where gravity is so strong that light itself travels in circles, trapped in a perpetual orbit. You look at your watch. Time feels normal. That's the cruelest part about this opening phase of your journey. Everything feels normal. Your heart beats normally. You breathe normally. If you had a cup of coffee, it would taste exactly like coffee. Nothing about your immediate experience hints at what is coming. But here is something that is already happening, something that nobody around you in the ordinary universe would be able to tell you, because they can no longer communicate with you effectively. The time you're experiencing is already running slower than the time back on Earth. This is not science fiction. This is Einstein's general theory of relativity, proven, measured, confirmed. Gravity warps time. The stronger the gravity, the slower time flows for the person inside it. You are already inside a gravitational field so intense that for every minute you experience, slightly more time is passing back home. It's only a small difference at this distance, but it's real, it's measurable, and it's only going to get more extreme. You have 55 minutes left. You're getting closer now, about 500 kilometers from the event horizon. The acceleration is building, and something new is beginning to happen that is, in my view, one of the most haunting phenomena in all of astrophysics. The black hole in front of you has begun to eat the light itself. When you look toward the black hole, if you dare to look directly at it, you see a perfect, absolute circle of blackness. Not the kind of dark you see when you close your eyes. Not the kind of dark in a room with no lights. This is a darkness that is structural. It is the absence of everything. No photons of light escape from beyond that boundary. Your eyes have literally nothing to receive. And surrounding that perfect circle of nothing is the most beautiful and terrifying thing you have ever seen. The accretion disk, a swirling ring of gas, dust, and plasma that has been falling toward this black hole, heating up through friction and compression to temperatures of millions of degrees, glowing in X-rays and visible light, both shining brighter than a star. Its colors shift from white at the inner edge, where it's hottest, to orange, then red, then a deep, blood-dark crimson as it spirals outward. And the light from the part of the disk behind the black hole is being bent up and over the top of the event horizon by gravity. So you see the disk not just in front of the black hole, but also arching above it, like a crown of fire hovering in space. You realize you are looking at one of the most beautiful things a human being has ever had the privilege of witnessing. And it is also the thing that is going to consume you. At this distance, the gravitational effects are serious. Loose objects near you are beginning to accelerate at different rates depending on how close they are to the black hole. Something held in your outstretched hand toward the black hole is being pulled more strongly than something held at your side. This difference, this tidal effect, is the beginning of something physicists call spaghettification. And yes, that's a real scientific term. And no, it's not gentle. You have 45 minutes left. Let's talk about something that most people never fully appreciate, because it requires you to think about the universe in a way that feels almost supernatural, even though it's perfectly scientific. Let's talk about what the people back on Earth, back in the ordinary universe, are seeing right now as they watch you fall. They're not seeing what you think they're seeing. Because of the way gravity warps time and light, anyone observing you from a safe distance would see your fall slow down. Not because you're actually slowing down, you're not, you're accelerating, but because the light that carries information about your position has to fight harder and harder against gravity to escape and reach their eyes. So to an outside observer, your motion appears to get slower and slower the closer you get to the event horizon. And here is the truly astonishing part. You would never appear to cross the event horizon at all. From the outside, you would seem to freeze, right at the edge, suspended in time like a photograph, a statue on the boundary of infinity. Your image would slowly fade and redshift, the light from your body being stretched to longer and longer wavelengths, first turning red, then infrared, then radio waves, then nothing, until you simply dimmed out of existence over the course of what would look like billions of years from their perspective. But from your perspective, You cross that boundary in a matter of minutes. No sensation, no yod, just an invisible line crossed in the darkness. Two people, same event, completely different experiences of reality. Both equally true. This is not a paradox caused by incomplete understanding. This is how the universe actually works. This is real. You have 35 minutes left. Now the tidal forces are growing. If you were oriented feet first toward the black hole, you would begin to feel a distinct difference in the gravitational pull between your feet and your head. Your feet are closer to the black hole, so they're being pulled harder than your head. The difference in force is called the tidal force, named because it's the same basic mechanism that causes ocean tides on Earth. The moon pulling the side of Earth closest to it harder than the far side. But here, it's not pulling water. It's pulling you. At this stage, it's uncomfortable, noticeable, like being stretched very gently but very persistently, your spine being pulled longer than it should be, your internal organs shifting subtly in directions they're not designed to shift. And this is where I want to pause the countdown for just a moment, because I want to tell you about the star that created this black hole. Because this moment, this uncomfortable stretching, this feeling of being elongated, this is a tiny, infinitesimal echo of what happened to that star billions of years ago. Our sun has been burning for about 4.6 billion years. It will burn for another 5 billion years approximately. Fusing hydrogen into helium in its core, the outward pressure of that fusion perfectly balancing the inward crush of gravity in a breathtaking equilibrium that has made life on Earth possible. But when a star much more massive than our sun, say 20 or 30 times the mass, runs out of fuel, that equilibrium collapses in an instant. The outward pressure disappears, gravity wins, and the entire mass of a star that dwarfs our own sun collapses inward in less than a second. Let that land. A star that took millions of years to build collapses in less than 1 second. The outer layers rebound and explode outward in a supernova, the brightest explosion in the known universe, briefly outshining entire galaxies. And the core, the dense remains left behind, compresses beyond the point where any force in nature can stop it. Electrons get crushed into protons. Neutrons pack impossibly tight. And then even that gives way, and the core collapses to a point of infinite density, a singularity, and the black hole is born. The black hole pulling you in right now was once a star. It burned for millions of years. It created carbon, oxygen, iron, gold, the elements that make up your bones, your blood, the air in your lungs. It gave those elements to the universe in its dying explosion. And now its corpse is pulling you apart atom by atom. There is a terrible poetry in that. You have 25 minutes left. You have crossed the event horizon. You don't know it. You felt nothing, but it happened. You are now inside the black hole. The universe outside, every star, every galaxy, every person you have ever known is still technically visible to you. You can still see light from outside. But here is what has changed, fundamentally and irreversibly. You can no longer send any signal back out. No light from your position can reach the outside universe anymore. No radio wave, no laser, no quantum signal, nothing. You are not just isolated. You are causally disconnected from the rest of the universe. The outside world continues, but you're no longer part of it in any meaningful physical sense. And here's the thing that haunts me most about this moment. The event horizon has a size. For the black hole you've fallen into, roughly 20 solar masses, the event horizon would be only about 60 kilometers in diameter. You could drive across it, but from inside, looking out, it appears to shrink and contract above you. The entire universe, all of space and all of time, appears to be compressed into a shrinking circle of light above your head, growing smaller and smaller as you fall deeper. You're watching the universe say goodbye to you, and there is nothing at all you can do about it. The physics has taken over. inside the event horizon. The direction toward the singularity is not a direction in space anymore. It has become a direction in time. Just as you cannot choose to stop moving forward through time in your ordinary life, here, inside this black hole, you cannot choose to stop moving toward the singularity. It is your future. It is as inevitable as tomorrow. You have 15 minutes left. Let's talk about what you would see. This is where the science gets genuinely strange in a way that most people don't expect, because the instinct is to imagine total darkness. But that's not quite right. In the first moments after crossing the event horizon, the light that was pouring in from the universe outside is still reaching you. It's still visible, but it has begun to behave strangely. It is blue shifting. The light from outside is being compressed as it falls inward with you, its wavelengths getting shorter and shorter, its frequency getting higher and higher. Light that was once visible becomes ultraviolet. Ultraviolet becomes X-ray. X-ray becomes gamma ray. The universe outside begins to look impossibly bright, impossibly energetic, the entire electromagnetic spectrum collapsing into a shrinking, blazing circle above you. Meanwhile, the world around you, the space you're actually in, is dark, profoundly dark. The accretion disk's glow is still visible, still circling somewhere in that tunnel of distorted light above you. But you're falling away from it faster than you can truly comprehend. And the tidal forces, by 15 minutes left, they would be severe. For the 20 solar mass black hole we've described, the tidal forces at this depth would be extraordinary. They would no longer be uncomfortable. They would be catastrophic. Your body, this miraculous, evolved biological machine, was not built for this. The difference in gravitational pull between your head and your feet would be so extreme that the molecules of your body would begin to be torn apart from each other. Your cells would stretch. Your proteins would unravel. The chemical bonds that hold together the atoms of your DNA, the blueprint of everything you are, would begin to fail. This is spaghettification in its full and terrible reality. You would not remain a person. You would be stretched into a long, incredibly thin stream of particles and atoms, your entire physical self converted into a thread of matter falling towards something that, right now, our entire civilization does not have the mathematics to describe. And yet here is the thing I keep coming back to. Here's the thing that I think about late at night when I'm looking at the stars. Even as this is happening, even as your atoms are being stretched and pulled and separated from each other in ways that no living thing has ever experienced before, the laws of physics are still working. The laws of conservation of energy are still operating. The information of what you are, every atom, every particle, every quantum state that makes you you, that information still exists. It is not destroyed. It is not erased. Where it goes is the most furiously debated question in modern theoretical physics. Stephen Hawking spent decades arguing that black holes ultimately destroy information. That when a black hole eventually evaporates through a process called Hawking radiation, a slow, painstakingly slow process that for a stellar mass black hole would take longer than the current age of the universe to complete, the information of everything that fell and would be lost forever. This would violate one of the most fundamental principles of quantum mechanics, which says information is always conserved. Most physicists today believe Hawking was wrong about this. They believe the information survives, encoded somehow in the Hawking radiation that seeps out. But nobody can fully explain how. This is called the black hole information paradox, and it remains unsolved. The greatest minds alive today are still wrestling with it. The answer might require a theory of quantum gravity, a theory that unites Einstein's general relativity with quantum mechanics, that we do not yet have. Your atoms might hold the clue, and we cannot reach them to find out. You have 5 minutes left. The singularity. Let's talk about what we think is there. I say think deliberately and carefully, because at this point, at the singularity itself, our equations fail. Literally fail. They produce results of infinity. And when a physical equation produces infinity, it is the universe's way of telling you that your theory is incomplete, that you're trying to use a map in a territory the map was never designed to describe. We know the singularity is a point, or perhaps a region, where density becomes infinite, where space-time curvature becomes infinite, where all the matter that has ever fallen into this black hole is compressed to a dimensionless point smaller than anything physics has ever described. Smaller than an atom, smaller than a proton, smaller than a quark, smaller than a Planck length, which is 10 to the power of negative 35 meters, a scale so small it makes atoms look like galaxies by comparison. At a Planck length, our understanding of space and time themselves breaks down. Space may not be continuous at that scale. Time may not be continuous. The concepts of here and now may cease to have any meaning. The very framework that all of our physics is built on, the assumption that space and time are smooth and continuous, may be wrong at the deepest level. Some theoretical physicists, like Roger Penrose, who won the Nobel Prize in 2020 partly for his work on black hole singularities, believe the singularity represents a genuine endpoint of space-time. That physics stops there. That questions like what happens next, or where does the matter go, are not just unanswerable, but meaningless. Because the next and the where require time and space to exist, and at the singularity, they may not. Others, those working on string theory, loop quantum gravity, or other approaches to quantum gravity, believe the singularity is an artifact of our incomplete equations. That in reality, something happens there that prevents true infinite density. That the matter bounces or tunnels or transitions into something else, perhaps a baby universe on the other side, a new space-time born from the death of matter in ours. Some of the most exciting recent theoretical work suggests that black holes might be connected to white holes, hypothetical objects that do the opposite of black holes, ejecting matter and energy rather than absorbing them, through something called an Einstein-Rosen bridge. A wormhole, a tunnel through the fabric of space-time connecting two different points, or perhaps two different universes, through a passage that, if traversable, would make the science fiction of interstellar travel look almost modest. We don't know if this is real. We don't know if white holes exist. We don't know if wormholes are stable enough for matter to pass through. We don't know what happens to you at the singularity. And I want to sit in that uncertainty for a moment because it is profound. We have landed on the moon. We have sent probes to the edge of our solar system. We have built machines sensitive enough to detect the ripple in space-time caused by two black holes colliding a billion light years away. We have photographed the shadow of a supermassive black hole, the one at the center of our galaxy, called Sagittarius A*, and another at the center of a galaxy 55 million light years away, called M87. These are real. These are documented. These are confirmed beyond any scientific doubt. And yet, the center of that object, the place where all that matter disappears to, remains the greatest mystery in all of science. You have 1 minute left. This is where I have to be honest with you. More honest than almost any science video will be. Because you want to know what happens in the last minute, in the last seconds. And the answer, the true, genuine, unvarnished scientific answer, is that we don't know. We don't know. Not because we haven't tried hard enough. Not because our scientists aren't brilliant enough. But because the universe has placed behind the event horizon a wall that cannot be crossed by any signal, any observation, any measurement. Everything that happens inside a black hole is hidden from the outside universe by the event horizon, absolutely and completely. We can theorize. We can calculate. We can extrapolate our equations as far as they will go before they break. But we cannot observe. We cannot verify. We cannot send a probe and receive data back. The inside of a black hole is, by definition, the most private place in the universe. And in those last seconds, as your atoms, stretched across perhaps thousands of kilometers of space, fall toward a point where everything we think we know becomes meaningless. Perhaps that is the most human thing about this whole journey. We are creatures built from the same atoms as stars, traveling through a universe we partially understand, falling toward mysteries we may never solve, and finding in that falling not just fear, but something close to wonder. The universe did not have to be comprehensible. It did not have to follow mathematical laws. It did not have to be beautiful. And yet it is all three. Even here, even at the end of everything, even in the last second before the equations break down and the physics runs out and the story of your atoms continues in a language we have not yet learned to read. The clock hits zero, and the universe keeps its secret. Think about what you've just understood. Think about how extraordinary it is that you're sitting here on a planet orbiting a medium-sized star in one of hundreds of billions of galaxies, and you just walked, mentally, philosophically, scientifically, to the edge of the most extreme object in the known universe, and peered over the edge into something that even our greatest geniuses cannot fully describe. You did that. Your brain, built by evolution to track predators on an African savanna, just grasped the curvature of space-time, just understood tidal forces and event horizons and quantum information paradoxes, just sat with the idea that time is not fixed, that space is not empty, that the boundary between existence and something we have no word for is a real, physical, measurable place somewhere in the darkness above us. If that doesn't fill you with awe, genuine, bone-deep, quiet awe, then I don't know what will. We live in a universe with black holes in it. Actual black holes. Thousands of them in our galaxy alone. Stellar mass, ones born from dying stars. Supermassive, ones millions or billions of times the mass of our sun, sitting at the centers of virtually every large galaxy ever observed, including our own. They are not science fiction. They are not metaphor. They are real objects in the real universe, bending real space-time, swallowing real matter, keeping real secrets. And we, these fragile, curious, brilliant, confused little creatures on this pale blue, have managed to detect them, measure them, photograph them, and begin to understand them. That is one of the most extraordinary achievements in the history of intelligence anywhere in this universe. At least, anywhere we know of. If you want to go deeper into any part of this, the physics of space-time, the story of Hawking radiation, the mystery of the information paradox, what's really at the center of our own galaxy, this channel goes into all of it. Subscribe and hit the bell so you don't miss what's coming. Because what's coming is even more mind-bending than what you just experienced. I promise you that. The universe is bigger, stranger, and more beautiful than any of us were taught to believe. And we're just getting started. Here is the question I want you to answer in the comments. And I genuinely want to know what you think, because there's no wrong answer here. And some of the responses on videos like this are more fascinating than the science itself. If scientists somehow found a way to send a probe into a black hole and transmit data back before crossing the event horizon, data about exactly what happens at the singularity, would you actually want to know the answer? Or is there something beautiful about having a mystery in the universe that we may never solve? Let me know in the comments below. I read every single one.